Good morning, scholars. Welcome back to the channel. This morning we're looking at types of triangles. So we're introducing the triangle. And there are several types. So I'm going to read the definition and explain as we go along. And then we're going to do an activity where we're going to identify what type of triangle we're dealing with. Alright, so listen to the definitions carefully, so that when it's time to do the activity, we can quickly identify which triangle we're talking about. So let's just revise the definition of a triangle. A triangle is a polygon, and if you don't know what polygon means, there was a video done specifically on polygons, so you can check out that video and bring yourself up to speed with where we are right now. So a triangle is a polygon that has 3 sides and 3 angles. The 3 angles of a triangle add up to 180 degrees. Alright, so actually the triangle is the first kind of polygon. A polygon is a many-sided figure, many angles, many sides. So the lowest number of sides and angles that a polygon can have is 3. Because the polygon has to be closed, enclosed, right? So remember, if you just have 2 lines, it can't be closed. So the triangle is the first polygon. It has 3 sides, 3 angles. The angles, all 3 angles in the triangle must add up to 180 degrees. Angles are measured in degrees, right? And this little circle at the right top of the number tells you this is the degree we're talking about, the measurement of the space that is formed between the 2 lines. That's an angle, it's measured in degrees. So let's look at the basic types of triangles. We have a right-angled triangle. The right-angled triangle has a 90-degree angle. So here, usually when the right-angled triangle is drawn, they don't write 90 degrees. What they do is they put this little box in the corner to indicate to you that this is our right angle. And you should know, as a mathematician, as a scholar of mathematics, you should know this is a 90-degree angle. Wherever you see this, it's indicating that it's a right angle. Now these are perpendicular lines. Perpendicular lines meet at right angle. We have a vertical line and a horizontal line. And it does not matter the orientation. By orientation, I mean the triangle doesn't have to be turning this way, right? We could have it looking like that. We could have it looking like that. We could have it looking like that. We could have it twisted all over the place, right? As long as it maintains, and if you want, you can orient it to the way that you prefer it to look, whether it's this way or that way. You can turn it just to check, right? But you should see the box to indicate that it's a right angle triangle. Or if the other 2 angles add up to 90, then you know this one must be 90 as well, since they all must add up to 180. So we have our perpendicular lines meeting at right angle. Alright, so the equilateral triangle. Equi here, the prefix equi means equal. So you can use that as a guide to remind you what the equilateral triangle is. An equilateral triangle has 3 equal angles of 60 degrees each and 3 equal sides. So remember, if we're saying that all the angles in a triangle must add up to 180 degrees, 180 degrees, and we're saying that the equilateral triangle has 3 equal sides, we are automatically saying that each side is 60 degrees, because 180 degrees divided into 3 equal angles, 3 into 18 goes 6 times, 3 into 0, 0. That's what we're saying. It must be this way. It must be. So the equilateral triangle always always will have 3 angles of 60 degrees each, because they must add up to 180. And if we divide 180 into 3 equal parts, we get 60. Alright, so the equilateral triangle, so these strokes along the sides of the triangle, once you're looking at a polygon or any object and you see these strokes drawn, wherever you see the same number of strokes, those sides are equal. So it's telling you this side is equal to that side is equal to this side. So if this is 20 meters, this is 20 meters, that is 20 meters. If it's 5 kilometers, 5 kilometers, 5 kilometers. The sides are equal. And the angles are always 60 degrees in an equilateral triangle. In the isosceles triangle, it has 2 equal sides and 2 equal angles and 1 that is not equal. So the 2 sides that are equal will form the 2 angles that are equal, right? If these 2 sides are the equal ones, then whatever this angle is the same. If this is 20 degrees, this is 20 degrees. This is 79 degrees, this is 79 degrees. This side is not equal to the other 2. This angle is not equal to the other 2. So basically what we're saying, since all the angles must add to 180, if you know this side and you know it's an equilateral triangle, you automatically know what this angle is. If you know this angle, you automatically know that one, they're the same. So you would just add them up, take that from 180 and you will get this missing one, because they must all add up to 180, right? So the isosceles triangle, 2 equal sides and 2 angles that are equal, and 1 side that's not equal, which is opposite to the angle that is not equal. Now, in the right isosceles triangle, it's a special isosceles triangle. So it still meets the definition of the isosceles triangle, where it has 2 angles that are equal. It's just that in this special isosceles triangle, those 2 angles are 45 degrees, which means that this angle must be 90, which also classifies it as a right angle triangle. So we call it a right isosceles triangle. It has the right angle, which qualifies it as a right angle triangle. And since this is 90 and these 2 are equal, so these 2 must be 45, 2 equal angles classifies it as an isosceles. So this is a right isosceles triangle, a special kind of right angle triangle, or you could say a special kind of isosceles triangle. And it will always look like this. The right isosceles will always have 2 45-degree angles and 1 90-degree angle. The scalene triangle, I would say, is the most common triangle because it has 3 different sides, 3 different angles. So the sides are of different lengths. So you notice it has 1 stroke, 2 strokes, 3 strokes. That indicates to you that the sides are of different lengths. None of them is the same as another. Which would also mean they have different angles. So we could put in here different letters to represent. So we could say that's X, that's Y, and that is Z. That's how I write my Z, weird. So X, Y, Z, 3 different angles, 3 different sides. That's a scalene triangle. Now we also have this guy here. He's called an obtuse-angled triangle. And remember we said though, an obtuse angle is an angle that is more than 90 degrees but less than 180. We know it has to be, no angle in a triangle can be 180 since all 3 must add up to 180, right? But the obtuse angle is more than, so it's a wide angle triangle, more than 90 degrees. And then of course the other 2 angles would be 2 acute angles. They must be far less than 90 for this guy to be more than 90. right? Because remember, all of them must add up to 180. So an obtuse-angled triangle has one obtuse angle, which is an angle that's more than 90 degrees, less than 180 degrees. And it has two acute angles, two angles that are less, usually much, much less than 90 degrees. So those are your basic types of triangles. So let's see if we can identify these triangles that we have over here. Some of the angles are not stated, but based on what we are given, we should be able to fill in the missing side and find out which triangle we're dealing with. So the first one, we are told this is 60 degrees, this is 60 degrees. If we add those up, we get 120. And if we take that from the full 180, 180 minus 120 is also 60. So we can fill in this 60 degrees, and immediately we recognize, as a matter of fact, I know the smarter ones recognized long ago, from you see 260 degrees in a triangle, the other one must be 60 also. So I know some of the sharper ones already knew that this is an equilateral triangle. It has three 60-degree angles, three equal angles. And we know if we had been given the sides would have been equal as well. Now here we have this triangle, 30 degrees, 60 degrees. We're not told what this is, but we can easily find out. Since we know all the angles must add up to 180, and we know these two, 30 plus 60 gives 90, the other one must be 90, so they didn't put it, but we're going to put it in. We're going to show that we know this must be a 90-degree angle, and this triangle must be a right angle triangle. It must be. If the other two angles add up to 90, this missing one here must also be 90, because 90 and 90 make 180, so we know that. Or how about this guy, 80 degrees, 45 degrees, 55 degrees. So the 55 and 45 add up to 100, plus the 80, that's 180, so 180 in all. There are three different angles. So which triangle has three different angles? That would be the scalene triangle. The scalene triangle has three different angles. Alright, how about this guy? We are told this is 40 degrees. And we are told that these two sides are equal. Immediately we can tell that must be an isosceles triangle. Must be. If it has two equal sides. This is 40. So the other two sides would be what then? If this is 40, so let's subtract that 40 from the 180. We're left with 140. And we have to divide that into two equal angles. So 140 divided by 2, that gives us 70. So we can put in here that this is 70 and this is also 70. 70 plus 70, 140 plus this, 180. But we could have told from a long time ago, just looking at it, because we're given the clues. These strokes tell us that those lines are equal, which would mean these two angles must be equal, and that's an isosceles triangle. Alright, looking at this guy, we're seeing that big angle. It's unusual to see a triangle with such a wide angle, but they do exist. They're rare, but they do exist. And looking at it, we see 120 degrees. Immediately we know that's an obtuse angle, because obtuse angles are more than 90 degrees, less than 180. So we can just go right ahead We don't have to waste any time. Go right ahead and show that we know. We know this is an obtuse-angled triangle. We don't have to waste any time. We see the obtuse angle. Here it is. And two acute angles. And remember I said those acute angles are usually much, much less than 90 because this big guy here is taking up all the space. And they still must add to 180. So these two will be very narrow, very tiny angles. Alright, so let's look now. We have 245 degrees. Which triangle has 245 degrees? 45 and 45 add to 90. And since they all must add to 180, this one must be 90. They left it out, but we're going to put it in to show that we know this must be 90. Which special triangle has a 90-degree angle and two 45-degree angles? So this is a special, really special guy. It's the right isosceles. It satisfies both criteria for, it satisfies the criterion for the right angle as well as the isosceles. It has a 90-degree angle. It must, because these two add to 90, this must be 90. So it has the right angle and it has two equal angles. So by definition, it's an isosceles. By definition, it's a right angle triangle. So it's a right isosceles triangle. Alright, here we have, this triangle has three different angles, which would indicate also three different sides. So we know that's going to be scalene. Three different angles, three different sides. This is a scalene triangle, and like we said, that's the most common one you're going to see. That's the most common triangle you'll see. Three different angles, three different sides. How about this fellow here? Let's see now. He has 30 degrees, 30 degrees. So those are two equal angles. We don't see any strokes, but we clearly are told these are two equal angles. So we know that's isosceles. What would be the missing one here? So these add up to 60. And if we take that 60 from 180, we get 120. So this one would be 120. So I think this guy would also classify as an obtuse angle, if I'm not mistaken. Am I correct, guys? Because 30 and 30, 60. If we take the 60 from 180, we get 120. 120 is obtuse. So this is also an obtuse angle, and it's also an isosceles. So we're going to put both, right? It's an obtuse angle as well as an isosceles. You know, you have some triangles, they just don't fit in with the rest. They like to be different. Just like some of us like to be different. We stand out. Okay, so so that's the basic definitions for the types of triangles, and we went through the activity and we identified, we showed that we know now how to identify any triangle that we see now. We're going to say you're that, you're acute, you're right angled, you're isosceles, you're a right isosceles, you're a scalene, you're an obtuse. We know them now. So guys, if you have been helped by this video, just drop a line, just drop a comment to say thank you, miss, I appreciate what you have done. And share the video so other students can have access to the information. We can't be selfish. Remember our mission, remember what we said our mission was? To remove the fear of mathematics that so many people still have. We want to dissipate that, scatter it till it fades. No more fear of maths. So you have to share the video then. So don't keep it to yourself. Share it so other students can see how easy it is. If there are any other topics you want me to do videos on, just let me know in the comments. I'm going to eventually be doing videos on just about every aspect of your syllabus, but if there's a particular one giving you some issues, just let me know and I'll do that video quicker than I planned. And if you haven't subscribed to the channel, please do so and click that bell so you can know immediately as soon as a new video comes out. You can be on top of things. Stay on top of things. Get the latest news. Alright guys, so I'll see you in the next video.